Hello everyone. In this video I am going to teach you how to delete a node from the circular linked list. Now first I'll teach you how to delete a node from the beginning of a circular linked list. See, this is the circular linked list given. First you want to delete the node at the beginning. First node you want to delete. See, what is the first step? You want to check whether the linked list is empty or not, because if the linked list is empty you can't delete any node from it. And so how to check whether the linked list is empty? See here, now I am taking tail pointer. Now there is no node present in the linked list, but tail pointer stores the address of last node. But if there is no node means tail will have 0. So if this is 0 means tail is 0 means no node is present in the linked list. So you can't delete, you should write print empty. So I am writing that condition. See here. If tail equals to 0, that means when the linked list is empty, print empty. You can't delete any element. Now this is the case when the linked list is empty. Now let's see the case when linked list is having only one node. See here. Now we are taking tail pointer. Now let's say there is only one node in the linked list. In the circular linked list. Let's say this address is 100 and data stored is 8. Now since this is circular means this is the last node. Now this 100, tail is 100, so it's pointing towards the last node. Now see, since this is circular, the pointer part stores the address of first node. This is the first node as well as last node because only one node is there. So address is 100 for the first node. So 100 is stored in the pointer of last node. This is the thing. Now see, now you want to delete this node. How to delete? See, now tail is pointing towards the last node. So if this node is deleted means tail does not point to any element. Tail does not store the address of any node. So first thing is you should update this tail pointer to 0. So this link gets detached. It gets removed. Now after you write tail equals to 0 means this node is not part of a linked list. Now but data is stored in this node. The data is stored in the memory. So this is a garbage value, so you should remove that data from the memory, or else it will cause a memory wastage. So how to remove? For that, now I should have an access to this node address, but there is no pointer pointing to this node address 100. First the tail was pointing to this node, but now tail is not pointing, so I should create another pointer called temp, and that temp pointer should point towards this node. Now before tail was pointing to this node at starting, so you should write at that time temp equals to tail. Then tail was 100 at before, then temp will become 100, then this points to this node. After that, after pointing this, then you should update the state value to 0. Then this link gets detached. Then after that you should remove this node by using free temp. Then this node will be removed. So let's see the case. See, now this is pointing to this node. Now tail is 100. Now see, I am writing the condition. If, how to check only one node is present? See here. Now this is the last node. In the pointer part of last node, if you contain the address of first node. So first node is 100. This same node is only 100. So 100 is stored here. So this is first node as well as last node. So you can say only one node is there. So I am writing the conditions here. If tail next equals to tail. See here, tail is 100. 100 next is what? 100. The same node. So first node and last node are same. So only one node is present. So what you should do? First you should create a pointer called temp, and that pointer should point towards this node. So I am writing at starting. Temp equals to tail next. Now I am pointing that temp pointer to the first node. So first node address is stored in the pointer part of last node. So see here, temp equals to tail is 100. 100 next is 100. So 100 is stored here. So temp pointer is pointing to this node. Now I should remove this link. So I am writing, see here, tail equals to 0. So it became 0. So this link is removed. Now you should remove this node from the memory. So I am writing free temp. Now temp is 100. So this node is removed. This is how you should remove. Now see, there is no node present in the linked list. This is how you should remove when only one node is present. Now let's see the case when there is more number of nodes. See, I'm checking the condition whether tail next equals to tail. Tail is 400. 400 next is 100. So there is more than one number of nodes. Now how you want to delete? See here. Now you want to delete this node, first node. So what to do? See here. Now this in the pointer part of last node is 400. In the pointer part I will store the address of first node, that is 100. Now if this 100 is deleted, this first node is deleted, means 200 will be the first node. So you should store here 200. So that is the case. You should update this value to 200. If you update this value, this pointer will point towards this node, 200 node. It does not point to 100. Now after making this change, what you should do? You should remove this node from the memory. So how to remove? Because if you don't remove, it causes memory wastage. So how to remove? For that I need a pointer pointing to this node, first node. But there is no pointer pointing to this node. So I am creating a pointer temp, and that temp should point towards this node. So how can I access 100? So 100 is stored in this temp, in this pointer part of 400. Before updating it to 200, 100 was stored. So at starting itself you should write temp equals to tail next. Tail is 400, 400 next is 100. You should store at starting itself. Then now you can write free temp, then this node will be deleted. So see here, I am writing this. Now temp equals to tail next. Tail is what? 400. 400 next is 100. So see here, I am writing 100. So this pointer is pointing to this node, first node. Now I should update this pointer part. So I am writing, see here, else tail next equals to temp next. Now see, tail next is what? Tail is 400. 400 next is this pointer. In that pointer I should update the value of temp next. Temp is 100. 100 next is 200, this pointer. So I am updating here 200. So this pointer gets cancelled, and this pointer is pointing to this node. Now this link is cancelled. Now there is only 3 nodes in the linked list. Now this is not part of a linked list. This first node is not part of a linked list. But now you should remove this from the memory. So how to remove? See here. Free temp. Now temp is 100. So you can remove the node which is having address 100. So you have removed this node at the beginning. This is how you should remove a node from the beginning of a linked list, circular linked list. Now see, now I'll teach you how to delete a node from the end of a circular linked list. See, this is the circular linked list. Now I should delete the node which is present at the last. See, first I'll teach you the case when the linked list is having only one node. See, I'm having only tail pointer now. This tail pointer stores the address of last node. So let's take only one node in the linked list. So let's say this address is 100 and data stored is 8. Now this is the last node. So 100 is stored in this tail address. So tail points towards this node. Now see, now I should make this circular. Circular means this is the last node. So in the pointer part of last node I should store the address of first node, because since it is a circular. So which is the first node? This is the first node, because first node and last node are same here. Only one node is present. So I should write the first node address, that is 100, into this pointer. So it creates a circular link. Now you have only one node. Now you want to delete this node. How to delete? See, suppose if you delete this node from the linked list, means the tail pointer will have tail pointer stores the address 0, because tail is used to store the address of last node. If no node is there, means it stores 0. So I am updating this 100 to 0. So this link will get cancelled. So this node is not part of a linked list. That means this linked list is empty now. But see, data is stored in this pointer. Data is stored in this memory. 8 is stored in the memory. So now this is garbage value. You should delete it from the memory, or else it will cause memory wastage. So how to delete? Now you need if you want to remove this from memory means you need to access this 100. From where you can access, there is no pointer pointing to this 100. So I should create a pointer called temp, and that temp should point towards this first node. Now how to get the address of first node, that is 100. Now first node address is stored in the pointer part of last node, that is here. So how you can access this pointer? You should access by using tail next. At starting, tail was pointing at head 100, so 100's next is this 100. You can get the address of first node. So before updating this tail, you should write the temp value equals to tail next. So see here. Then I'll write the code and teach you. See, now it's pointing at 100. First I'll write temp equals to tail next. Now what is tail next? Tail is 100. 100 next is 100. So it's put on temp. So this pointer is pointing to first node. Now I should remove this tail pointer. I should remove this link. First I should check whether the it is containing only one node. So how to check? See here. If tail next equals to tail, that is see, tail is 100. 100's next is 100, that is equals to tail. Tail is also 100, so it's equal. So it contains only one node. That means if the node of you are finding the pointer of this last node, that pointer should have the address of first node. So if the address of first node is same as the address of last node, then you can say it has only one node. So I am doing, see, now what step I should do? I should remove this link. So tail equals to 0. So this tail becomes 0. So this link is got cancelled. Now this is not part of a linked list. Now I should remove this node. How to remove? Temp is pointing to this node. So see here, free temp. Now temp is 100. So the node 100 is removed and that link is also removed. So this is the case for removing only one node in the linked list. If there is one node only, then you can remove by this step. So now let's see the case when there are more than one node present in the linked list. See, it's checking if tail next not equals to tail. See, tail is 400. 400 next is 100. So this tail next is 100, and what is tail? Tail is 400. 100 is not equals to 400. So you can say that there are more than one node present in the linked list. So what you should do? See, now you want to delete the last node. How to delete? See, now if you delete this last node, if you delete this 400, then 300 will be the last node. So you should create a circular link here. Now in the pointer part of last node, that is here, you should store the address of first node to make it circular. So address of first node is 100. 100 you should update it to here in this pointer. So it creates a circular link like this. Now this link get cancelled. Now this is the first change you should make. Now see, now for accessing this pointer, you want to update this pointer, right? For accessing this pointer, you need to know this address 300. Now there is no pointer to point to this 300. If we have pointer only, we can access this 300. From where we can access? So I am creating a temp pointer. Sorry, previous pointer. Now this previous pointer should point towards 300, but it can't directly point to any node in a linked list. First, previous pointer should start at first node. It should point at first node. So see, I am creating a previous pointer, and previous pointer should point at first node. Then at each step, one by one, it points at 100, then it moves to 200, then it moves at 300, then it stops here. It moves one step forward till it reaches 300. This is how you can point to 300. Then see, now in this pointer, I should store the address of first node, that is 100. Now where can we get this 100 from? 100 is stored in the, that is address of first node is stored in the pointer part of last node here. So you can get this pointer by using tail next. Tail is 400, 400 next is this thing you can get. Now see, this is the first step. Then after making this change, you should move this tail pointer to 300. Why you are moving? See, tail pointer is a pointer which stores the address of last node. If this node is 400 is deleted, means 300 will be the last node. So it should store the address 300. Then this pointer will point to this thing and this link will get cancelled. Now see, now this is the node which is garbage. Now you should remove this node from memory or else it will cause memory wastage. So how to remove it? There should be pointer pointing to this node, but this 400 was stored here, but it is updated to 100. So you can't access this node. And tail pointer is also updated to 300. So you can't access this node. So how to access? So I need another pointer called temp. And temp should point to 400, but it can't directly point to 400. First it should point to first node, then it should move one by one till it reaches 400, then it should stop here. So let's see how to do. See here. Then afterwards if you write free temp, this node will be removed from the memory. So let's see. Now this link is not cancelled and this values are not updated. Now this tail pointer is pointing to 400. Now see, now let's see what to do. Now I should create a pointer called pre-temp, and temp should point to the first node. So see here, temp equals to tail next. So I am creating a pointer called temp. And what is tail? Tail is 400. 400 next is 100. 100 is stored in this temp. So it's pointing to first node. Now see, while temp next not equals to tail next. Now what is this condition? While temp next not equals to tail next. This condition is used as terminating condition. See, I should move this temp pointer one step forward till it reaches 400. It should stop here. After that it should not move to next node. So that's why next node means it again does not go to 100. So that's why this is the stopping state condition. Now see, now first step is while temp next not equals to tail next. Temp is what? 100. 100 next is 200. 200 is not equals to tail next. Tail is 400. 400 next is 100. 200 is not equals to 100. So what you should do? You should create another previous pointer which is pointing to first node. So previous equals to temp. Now see, now I am creating another pointer called previous. Now what is temp? Temp is 100. So 100 is stored here. So this pointer is pointing to first node. Now see, now next step is I should move the temp pointer to next node. So 200 should be stored in this pointer, in this temp pointer. Where can you get 200? From this pointer. So temp equals to temp next. Now see, temp is 100. 100's next is 200. 200 is stored in this temp. So this link is cancelling. It's not pointing to first node. Now it's pointing to second node. Now go back to the same step and check while temp next not equals to tail next. Temp is 200. 200's next is 300. This is 300. Now what is tail next? Tail is 400. 400 next is 100. So 300 is not equals to 100. So enter into the step. Previous equals to temp. So what is temp? 200. So 200 is put on previous. So this pointer is getting cancelled and previous pointer is pointing to 200. Now temp equals to temp next. Temp is 200. 200 next is 300. 300 is put on this temp. Now this link is getting cancelled. Now temp is pointing to 300. Now go back to the same step and check whether temp next not equals to tail next. Temp is 300. 300 next is 400. Now what is tail next? Tail is 400. 400 next is 100. So 400 is not equals to 100. So enter into this step. Previous equals to temp. What is temp? 300. 300 is put on this previous. Now this previous is pointing to 300. Now temp equals to temp next. That means move the temp one step forward. Temp is 300. 300 next is 400. So 400 is put on this. So this pointer is getting cancelled. And this pointer is pointing to 400. Now go back and check the condition. Temp next not equals to tail next. Temp is 400. 400 next is 100. Now what is tail next? Tail is 400. 400 next is 100. So 100 is equals to 100. So this condition is false. It is not coming as not equals to, it's equals to. So you don't move this previous pointer one step forward and temp pointer does not move one step forward. It stops here. Now what to do? See here. Now in this pointer part, I should store the address of first node, that is 100, to make it circular. So how to access this pointer? By using previous next. So I'm writing here, see, previous next equals to tail next. Now see, previous next is what? 300 next is this pointer. In that pointer I am storing the address of tail next. Tail is 400. 400 next is 100. So 100 is stored here. So this link got cancelled. And this pointer is pointing to the node which is having first address. Now see, now you should move this tail pointer to previous node, because tail should point to the last node. Now this is the last node, 300 is the last node. So how to move? See here, tail equals to previous. Now what is the previous? Previous is 300. 300 is put on tail. So this point is getting cancelled and tail is pointing to 300, this node. Now what to do? Now you have created a circular linked list with 3 nodes. Now this is not considered as a part of node. Now this is a garbage value. Now you should delete this from memory, or else it causes memory wastage. So how to delete? See here. Now 400 is accessed through this temp pointer. So I am writing free temp. Now what is temp? Temp is 400. So the node 400 is deleted, and the link which it creates is also deleted. This thing, and this temp pointer is also deleted. So see, you have deleted that last node, and now you have only a linked list with 3 nodes, circular linked list with 3 nodes. This is how you should delete a node at the end of a linked list. Now I'll teach you how to delete a node from a particular position in the circular linked list. See, now I should ask the user at which position I want to delete the node. So I'm writing the code here. Printf enter position. So the user it asks to enter the position. So if the user enters some position, the value in that means that value should be stored in this position variable. So how to store? By using scanf function. So I'm writing here, see, scanf %d comma and position. Now the value which user enters is stored in %d. That means %d is what? Position. It stores in position. Now see, now there are 4 nodes in the linked list. Suppose if the user asking the position, at what position you want to delete. Suppose if the user enters 5, that means 5th node should be deleted. But there is no 5th node in the linked list, so you can't delete. So it should print invalid. So how to find how to write that condition? See, if the user enters some position that is greater than number of nodes present here, means it prints invalid. So I'm writing the code here. This position is 5. 5 is greater than 4. So it prints invalid. I'm writing the condition. See, if position greater than count, count is number of nodes in the linked list, then print invalid. Now it prints invalid. Now it again asks the user to enter the correct position. So if the user enters position is 3, means third node should be deleted. This node 300 should be deleted. Now how to delete this node? Let's see. See, now if this node is deleted, 300 is deleted, means in this pointer part of 200, in this pointer I should store the address of next node. That means if this node is deleted, means what is the next node of 200? It will be 400. So I should store 400 in this pointer, like this. So this pointer will point towards this node. Now this link will get cancelled. So this is the first step. Now see, now for accessing this pointer, I should update this pointer, right? Now for accessing this pointer, I should know the address of this node, that is 200. But there is no pointer pointing to 200. So I should create another pointer called previous. Now previous should point to this node. Now but previous node cannot be directly pointed to any node. Any pointer can't directly point to any node. In the linked list, first it should point to the first node, then at each step it moves one by one. This previous pointer will point to 100, then next step it will point to 200, then it goes one step forward, then it stops at 200. So how to do? Let's see. Then I can update this value. I should put 400 here. Then what to do? See, now this node is not part of a linked list, but you should remove this from memory because data is stored in it. So how to remove this garbage value? By using a pointer. I should have a pointer pointing to this node, but there is no pointer pointing to this node. So I'll create another pointer called next node, and that next pointer should point to this node, but it can't directly point. So see, this previous pointer was moving one step and it had reached 200. Then after it's reaching 200, then you can write next equals to previous next. So previous was 200, 200 next is 300. So this next, in this next pointer 300 will be written and it's pointing to this node. Now you can write free next, then this node will be deleted from the memory. So let's see how to do. See here, now else part. Now this link is not there. Now this link is not cancelled and this pointer is not updated. Now see, now previous equals to tail next. That means previous should point to the first node, but there is no head node pointing to this. So where can we get this 100 from? It's stored in the pointer part of last node. So see here, previous equals to tail next. I'm creating a previous pointer, and that tail next is what? Tail is 400. 400 next is 100. 100 is stored in this pointer. So this pointer is pointing to 100. Now see, now next condition is while I less than position minus 1. What is this condition? See, now previous pointer should move one step forward. Then when it reaches 200, then it should not move again. It should stop at here. So that's why this terminating condition. Now what is this I? I is a variable which tells at which position does the previous pointer point at. Now at starting, previous pointer is pointing to first node. So I will be 1 at starting. So I will declare here int I equals to 1. Now I is a variable. Now it takes 1. Now see. Now what to do? Now check this condition, whether I less than position minus 1. I is 1. What is position minus 1? 3 minus 1, 2. 1 is less than 2. So it enters into this condition. Now what to do? Now I should move this previous pointer one step forward. So previous equals to previous next. Now see, what is previous next? Previous is 100. 100 next is 200. So 200 is stored in this previous pointer. So this link is getting cancelled and this pointer is pointing to 200, this node. Now see, now previous is pointing to second node. That means I should be 2. So increase I value by 1. So how to increase? I plus plus. So now it's updated to 2. So this thing. Now see, now go back to the same condition and check whether I less than position minus 1. I is 2. What is position minus 1? 3 minus 1 is 2. So 2 is not less than 2. It's equals to 2. So this condition is not satisfied. So it does not enter into this step. That is, previous pointer is not moved to next node. It stops here. Now see, now I should take another variable next node that should point at 300. So I am writing the code. See here, next node equals to previous next. Now see, I am creating a pointer called next node. Now what is previous next? Previous is 200. 200 next is 300. 300 is stored in this pointer next node, and this pointer is pointing to this node. Now see, now what changes you should make? In this pointer I should store the address of 400 next node. If this node is deleted, the next node of 200 will be 400. So I should store here 400. How I can store? See, now in this now the pointer I can access by previous next, and this address I can access by next node next. So see here, previous next equals to next node next. Now see, previous next is what? Previous is 200. 200's next is this pointer. In this pointer I should update the value of next node next. Next node is 300. 300 next is 400. So I am updating here 400. So this link got cancelled and this pointer is pointing to the node which is having 400. Now this node is not part of a linked list, but this is a garbage value. How to delete this garbage value? See here, next node is pointing to that node. So I can write free next node. So free next node. Now what is next node? Next node is 300. So this node 300 is deleted, and this link also gets deleted, and this pointer next node is also deleted. Now see, now you have a linked list with circular linked list with only 3 nodes. The node at position 3 is deleted. So this is how you should delete a node at a particular position in the circular linked list. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.